Hello world and welcome to Learning Java one byte at a time. This is the 15th video in a tutorial series geared at bringing the wonderful wide world of Java to those with little or no programming experience. So far we've had a pretty good opportunity getting our hands dirty working with the nitty-gritty of the Java fundamentals. We've touched on integers for storing numeric data and strings for storing character data. We've also worked a little bit with program flow and logic, such as if-then statements and for and while loops. And we've also touched on classes and how to declare a class and how to instantiate an object from that class and assign it states and behaviors. So now I thought was a really good time to talk about variables and dive real deeply into the concept of variables, their ranges, their use cases, and how to cast or convert them. Now, why would I wait so long in a tutorial series to talk about something that's so essential to the programming language? The reason being, in my experience, learning a new language, variables tend to be one of the first concepts thrown at a person, and they tend to be so content-laden. There's so much information involved with variables that much of it's just lost because there's no context of the programming language. And so now that we've actually worked a little bit with Java, I'm hoping that most of this information will be a little bit easier to retain and make a lot more sense within the context of the Java programming language. And so without further ado, I'll dive into my Notepad++ application. And everything in this video is going to be a lot less coding and a lot more information overview. And so bear with me if it's a little bit dry, but this is sort of necessary information. And hopefully, again, like I said, that having the background of Java that we have at this point, it's going to make a little bit more sense and be a little bit more easier to digest. And so variables. What is a variable? When do you use it? When do you call it what you call it? What's the nomenclature? What's the convention? I want to talk about all of that right now. And so here in this file that I have named the class variables, I have a couple of different declarations and assignments and even a few methods using variables. And so this gives us the opportunity to look at variables a little bit more deeply and to see exactly what the nature of variables is given the structure of Java as a programming language. And so here in the class of variables, I have declared 3 class level variables. And if you can remember from previous videos, the class level variables are often going to be static if they're going to be pinned to that class. That means that if there's an object created from that class, those variables are not going to be copied. They're not going to be instantiated with each object. They're going to be sort of stuck to that class at a class level. And if they are not static, if they're instance variables, then they will be copied onto the object, but they can still be declared at a class level. Now, the only thing that declaring a variable at class level means is that it's going to be accessible from everywhere in that class. Now, you can see here, I have a private, public, and final variable that I've declared in the class that I've called variables. And these modifiers actually mean specific things, and it's important to understand the difference between them. And so if you declare a variable as being private, you're essentially saying that only whatever the scope of where I'm declaring this has access to this variable. And so by declaring this variable as private within this entire class, it means that every method in this class can access the variable, but were another class tried to make a call to this class or instantiate an object and then make a call to the variable through that object, that the class of variables would say, whoa, whoa, whoa there, mister, that's a private class. You don't have any access to that. Now, on the contrary, a public class is accessible from other classes or from other classes creating instances of objects and then calling them through that object. So right here I have a private static integer called myInt and a public static integer called myOtherInt that I'm assigning the value of 0. So the difference you see here is one is just a declaration and the other is a declaration and an assignment. What makes this interesting is that in Java, declaring a variable at class level means that you can instantiate it right at the declaration, or you have to wait till you're within a method to instantiate it. And so if I declare the private static myInt right here, and then down here attempt to assign it a value, this would actually flag a compilation error. This is not allowed. I can declare it at class level, I can declare it and assign it at class level, but I can't declare it and then on a separate line make an assignment. I can only assign it within a method of that class. And so this variable, public static int, that I've called myOtherInt, I'm also assigning it within the declaration level, and I'm assigning it a value of 0. Now, lastly, this one that I've modified as a final variable, this is a final static integer that I've named 2, and I've assigned it the value of 2, again in line as permitted by Java. The final keyword just means that you know for sure that the value of this variable is not going to change through the entire lifetime of the program. And what that does for Java is it allows Java to free up the memory resources it would otherwise be allocating to that variable on the chance that the value is going to change. And so examples of what you would use as a constant, as declaring a variable as final, would be if you had a variable called, let's say, days in the week, and you set it equal to 7. So this makes sense within the context that 7 is a value of the variable days in the week, and this variable is never going to change its value. The days of the week is always going to be equal to 7. And so it might be something you need to reference in your program, but it's never going to be a value that's likely going to change. And again, that gives Java the chance to free up those memory resources. Now you've noticed that unlike the camel casing that I'm using for my int or my other int, with the constants, I've used all uppercase and then I separated the spaces with underscores. And this is just convention with programming. This is what programmers will recognize as being a constant just by looking at the variable name. And so it's not strictly necessary, but it is really good practice. And so this final static int that I've called 2, I've set equal to the value of 2. And since 2 is always going to equal 2, I've made it a constant. I'm essentially never going to change the value of 2. This variable 2, this constant 2, will never equal 3. It just wouldn't make any sense. All right, so that's a little bit about class level variables. Let's touch down on the local variables or the method level variables as opposed to global variables that we just covered. So inside this main method, I am declaring another variable. This is going to be a local variable to the main method, and it's a string variable that I'm calling myString. Now I'm not assigning it a value, I'm just declaring it, but I'll assign it a value a little bit later. And then down here I'm taking a class level variable, myInt, that I declared up here, and I'm now making the assignment in a legal way that's within a method. And I've assigned it the value of 100. Now down here, I'm going to go ahead and make the assignment to the string variable that I declared up here at the method level, and I'm going to assign it a really interesting value. So it being a string variable needs to have string data. It needs to have character data. If you assign a string variable integer data, like I have right here, I'm assigning it the value of 100, it will automatically convert the numeric data to character data. It's still going to read 100, but it's going to be 100 as far as text goes, not 100 as far as a numerical value goes. And that's kind of nice with Java, is that you can do that automatically. You can assign an integer or other types of numeric data to strings, and it will just convert that into character data, but it will still read the number that you want it to read. And so this variable, this class level variable that I'm now making an assignment of 100 to, I am now assigning that to my local variable, myString. But it's going to be a little bit more than that. I'm using the concatenator to also add some literal text, and then another concatenator to add something else. And what this is going to be another method that I've called doubleIt, which I'm passing through what's called an argument. So now this is another type of structured variable. If you're passing a variable through to a method that accepts it, you're passing it through as an argument. Now down here in the method doubleIt, you see, as we've seen before, it's accepting the integer, it's expecting one, and it's going to call it some int. I'm passing through the myInteger right here into the function doubleIt, and down here it's what's known as a parameter. So in the declaration of the method, while you're writing the method, you're saying, I expect that when this method is called, it's going to be receiving an integer. I don't know what that integer is or what it's going to be called, and so I'm just going to say some int. So every time I say some int, just understand that I'm talking about whatever integer it happens to be passed through in that case. And when it's passed through here, it's called a parameter. And when you're passing it through, when you're calling it, that is when you actually know what it is, it's called an argument. But this is essentially the same thing. It's just that down here I don't know what it's going to be, and up here I do know what it's going to be. Now, the fact that it's expecting a parameter called int means that it won't work without that. I mean, if I try to call it without passing an integer, it's not going to know what to do with itself. So before we get further into that method, let's come back here to the assignment of the string variable, myString. So I'm setting it equal to a number that we've already talked about will be converted into text. Then I'm going to concatenate some more literal text with it. This text is going to be a space times 2 equals and then a space. And then I'm going to concatenate the calling of this method and passing through an argument. Now, we talked a little bit before in a previous video that methods can actually be evaluated, that certain methods can actually have a value, and that value comes from the return of the method. Most methods we've written in Java so far have been void methods. They've been methods that don't return any data, or they return void data. And so those methods can't be evaluated because they're not returning anything. However, in the case of doublet, I'm actually returning the integer, and the integer I've declared as the return type in the method signature, which is this right here. So upon declaring the method, I'm not only declaring that it's public and that it's static, but I'm also declaring that it's not going to return a void, it's actually going to return an int. And that int is going to be returned at the end of the method down here. And so by calling this method and passing through the arguments, I'm actually essentially saying this is going to result in a value. I don't know what that value is going to be, but go ahead and concatenate that value to the rest of the string. And that's the really interesting thing about methods that return values, is that they can represent values themselves. And so just assume that this is going to be a number and treat it like a number within the context of making an assignment to this variable. So now right here I'm just printing out the string variable to the screen, and we'll go ahead and run the program to see if it's actually correct. If it is, it should say 100, which is the value of my int that I've assigned up here, plus the literal text times 2 equals, and then, as you can probably guess, the method doublet passing through my int. So I'm passing 100 through to a method that's going to double it, so this should evaluate to 200. So this whole text should say 100 times 2 equals 200, if I've done it correctly, and we'll see that in just a moment to see. But before we do that, let's talk a little bit about this method that I've written called doublet. So I've declared it as being public, which means it can be called from anywhere inside this class or any other class that's making calls to this class. I've declared it as being static, which means were this class to make any objects, this method would not be instantiated upon the creation of each object. It's going to be stuck to this class at large. I've declared the return type as being not void, but in this case an integer. And then doublet is just a name of my choosing. This is just how I'm going to refer to this method throughout any other place in this program. And then here in the parameters, I've said expect it to be an integer, and for the whole method here, we're just going to call it sumInt, because again, we don't know which integer is going to be passed through. So whatever it is, just call it sumInt, and when I say sumInt, I'm talking about that integer, whatever it may be. Down here we have another local declaration of a variable. This is another integer that we're calling local int without an assignment. And then down here we're going to assign it, which is completely legal because I'm within a method, I'm not within a class. I'm going to assign the local variable that we've called local int some sort of calculation. And the calculation is going to be sumInt times the constant 2. SumInt, as we know, is going to be whatever is passed through, and the constant 2 we know has the value of 2. And so assuming that my int, which is equal to 100, is passed through, we're going to multiply that by the value of my constant 2, which we know is 2, which means that local int is going to wind up with the value of 200. Now, down here, I'm taking the class level int that I've called myInt, and I'm incrementing it. And the way that I'm doing that is with a plus plus. This is shorthand for something like this. I could type myInt equals myInt plus 1, and that would be the same thing, but just for shorthand, I'm going to do myInt plus plus, and that does exactly the same thing. It just adds 1 to itself. Similarly, you could also do myInt minus minus, and that's going to be a decrement. And there are also some more subtleties and nuances to doing this, but we're not going to cover that just quite yet. That's sort of outside the scope of where I'm trying to go with this. And then finally, the very last thing of a method that has a return type, I need to have a return statement and actually return some sort of value. And this is going to be, in the end, after all said and done, what this method is going to evaluate to. In this case, I'm returning local int, which is an integer, which is fair because I'm declaring that I'm going to return an integer. And the value of local int, as we've seen within context of this program, is going to be equal to 200. So again, that 200 comes back here and attaches itself to the string. So let's go ahead and run this program and see if we can actually get it to type out 100 times 2 equals 200, which is the expectation I have. So we'll jump in here to the command prompt. We'll go ahead and run the variable program. And as expected, the variable myInt converted to string data, plus the literal concatenation of a times 2 equals, plus a return value of a function or a method, which is in this case equal to 200. So we have successfully typed to the screen 100 times 2 equals 200. All right, not very impressive, of course, but this is all the beginnings of something that can be really incredible. And so that's variables. I feel like that's pretty good for one video. I have 2 more concepts to touch on, which is going to be the range of the different types of variables in Java, and after that, typecasting or converting one variable to another. But for the purpose of this particular video, I would say that we've called it good. I really hope this has been educating and informative and entertaining, and I look forward to seeing everyone back again in the next video. Thank you so much for making it through, and have a wonderful night.